My dear students, today we will discuss Gate 22 ECE network problems with the solution. So what are the questions asked in NT network theory in Gate 22 for ECE branch students? So let us start with this question. Current I in the circuit shown. So this is the network given 5 volts. Then current source of 10 power minus 3 amps. So it is one T network 2K given. Here is asking find I. So options are given. So we can solve easily. Using superposition theorem. Using superposition theorem. So using that, if I take source only 5 volts, I take only 5 volts. Obviously this current source is open. We take only this voltage source. (2K), this is 2K, 5 volts. So let us assume this current of I1. Current source is anyway open. So what is I1 from this? Is 5 volts by, this is anyway open, current will not flow. So 2K series, so it is 4K. This is I1. Now when other source is present, this is shorted, this voltage source is short. Now we have only a current source of 1 milliamps. Now this is 2K, 2K. But this current is going this way, so current will flow like this. This current I am calling I2. So this voltage source is shorted. So what is the value of I2? This incoming current is 1 milliampere dividing between 2K. So I2 will be 1 by 2 milliamps. What is the total current I? Is I1. I1 is going this way. I2 is going opposite. So minus I2. So this is 5 by 4 milliamps minus 1 by 2 milliamps. So this we have to simplify. We will get 0.75 milliamps. 0.75 milliamps. So B is correct. So you need not draw these circuits in the exam really. You can just imagine open. So current will flow like this 5 by 4. Imagine this is short. This current is dividing equally. So that is minus half. This will be divided. And simply add them, you will get the 0.75. This is another simple question. Consider the circuit shown in figure. The current I flowing through the 10 ohm resistor is. So in this we have to find I. So if you imagine current is flowing through 10 ohm, there must be a return path to come back. So this return path is not closed. These two endpoints not closed. So therefore, if current is flowing means it should come back. If it is coming only, then only it will go. So therefore, this I equal to 0. There is no closed path. There is no closed path. Therefore, I is equal to 0. So here B is correct. This is on locus diagram. So the circuit shown, the locus of impedance Z j omega. The impedance as a function of omega is plotted as omega increases from 0 to infinite. 0 to infinite. The value of R1 and R2 are. So for this circuit, Z of j omega plot is given here. And at omega equal to 0, impedance is 5. At omega equal to infinite, impedance is 2. So with this setup, you have to find the value of R1 and R2. So what is the clear given data? Omega equal to 0, impedance should be 5. At omega equal to 0, 0 frequency, what is the capacitive reactance? So Xc is what? Minus J by omega C. 0 frequency means value is infinite. At omega equal to 0, something by 0, so capacitive reactance is infinite. Means capacitor behave like open. When it is open, how circuit looks like? So this capacitor is open. Here it is R1, this is R2. This capacitor open. So what is the impedance given? At omega equal to 0 given as 5. So 5 is equal to, and these two are in series, R1 plus R2. So this is one equation. Second, at frequency infinite, impedance is 2 given, and frequency is infinite. So at infinite frequency, at omega equal to infinite, what is Xc? Capacitor reactance is 0. So capacitor behave like short. When capacitor is shorted, how the equivalent circuit looks like? So this is shorted. And this is R1. And what is this equivalent is 0. And what is the impedance given is 2. So 2 is equal to R1. So this is second equation. So straight away here R1 we got it as 2. If you substitute R1 2, what is R2 value? 5 minus 2 is 3. So R2 is 3. Here these values are given in kilo ohm. So obviously this is 3 kilo ohm. And this is also 2 kilo ohm. So R1 is 2 kilo ohm, R2 is 3 kilo ohm. So A is correct. R1 is 2 kilo ohm, R2 is 3 kilo ohm. That's all. So just with the help of these two extreme points, we are forming two equations and easily we are getting R1 and R2. This is another little bit carefully how to solve. Consider the circuit shown in figure with input V of t in volts. So this V of t sin t, this is volts given. The sinusoidal steady state current I of t. So this I of t flowing through the circuit is shown graphically, where t is in seconds. The circuit element Z can be. Circuit element Z can be. So here I of t given positive peak of 1 by root 2, negative peak of minus 1 by root 2. But if you observe at t equal to pi by 4, sine is becoming 0. At t equal to pi by 4, sine function is becoming 0. That means what is the I of t? The I of t, what is the peak value? 1 by root 2. 1 by root 2 sine t minus pi by 4. So at t equal to pi by 4, its value should be 0. What is the phasor form? 1 by root 2 of angle minus 45. So in phasor form, ideally we take RMS, but I am taking maximum. At the end, answer remains same. The same way, what is V of t? This peak value is 1, so 1 of angle 0. So voltage in phasor form, current in phasor form, what is the total impedance? Is V of t by I of t. So that is 1 by root 2 angle of minus 45 voltage 1 of 0, current 1 by root 2 angle of minus 40. So this is equal to root 2 angle 45 is nothing but 1 plus j. So Z of t is 1 plus j. But what is the total impedance Z of t? Is 1 plus z. It is 1 ohm given, this impedance is z. So 1 plus z is given, we got it as 1 plus j. So what is z value here? J. So this must be either inductor or capacitor. So only j means plus j means inductor, but inductor value also we have to find. If it is inductor, it is j omega L. What is omega source frequency given? 1. So omega equal to 1. This is given. So this is 1, JL equal to J. If you solve, what you get L value? 1. So L is 1 Henry. So inductor of 1 Henry. This is correct. This is the last question. For ECE students. A linear two-port network is shown in figure. An ideal DC voltage of 10 volts connected across port 1. A variable resistance R is connected across port 2. As R is varied, the measured voltage and current at port 2 is shown in figure. figure B as a V2 versus minus I2 plot. Note that V2 is 5 volts, I2 0, means open circuit voltage. And V2 is 4 volts, I is minus 4 milliamps. So that is already you can observe. V2 is 4 volts when I2 is minus 4. Minus I2 is 4 milli means I2 equal to minus 4. When the variable resistance R at port is replaced by a load shown in figure C, the current I2 is in milliamps. So first this V2, I2 characteristics are given. Always any network, if you consider this as a complete network, looking from the terminals with the help of VI characteristics, you can get the Thevenin equivalent. So Thevenin equivalent means V Thevenin and I Norton. If you get it, V Thevenin by I Norton will give you R Thevenin. So here when current is 0, what is the open circuit voltage here? What is VOC or V Thevenin is 5 volts. This is over. Now short circuit current straight away not given. You imagine project, if it is imagined like this is projected back, somewhere it will intersect. So that point value is nothing but ISC. How to find ISC? This is like a y equal to mx plus c equation. Y equal to mx plus c, not passing through RG. What is y here? V2. What is the slope vertical variation? 4 minus 5. 4 minus 5 by what is horizontal variation here? 4 milliamps, here 0. So 4 milliamps only. What is the x variable? Minus I2. Plus C is the intersection of line with the y-axis. So where it is intersecting? 5. Now to find the short circuit current, voltage will be 0. So if I equate 0, this will be minus, minus will be plus. So I2 by 4 milli plus 5. So what is I2 value here? I2 is nothing but ISC. Here I2 is going inside, but short circuit current will be outside. That means what? ISC is nothing but minus I2. So what is minus I2 value? Here this will be 5 is coming this side. So 5 into 4, 20 milliamps. Minus I2 value will be 20 milliamps. Now find out R Thevenin. What is R Thevenin? V Thevenin is 5 volts. Short circuit current is 20 milliamps. So if you simplify, you will get 250 ohms. You will get 250 ohms. Now problem started. When the variable resistance R at port 2 is replaced by the load, now you connect the Thevenin equivalent. What is V Thevenin? 5. What is R Thevenin? 250. What is the load connected is this 1K, then 10 volts. The current I2. So what is I2 direction is this. So this I2 we have to find. So how do you find I2? It is nothing but 10 minus 5. 10 minus 5 by 250 plus 1K is nothing but 1250. So 10 minus 5 by 1250, simplify, you will get 4 milliamps. So this is the answer. So it's a application of Thevenin's theorem. Application of Thevenin's theorem. This problem comes under theorems. So theorems, we got one problem. This problem comes under a steady state analysis concept. Steady state analysis. Those concepts, if you know, you can do this. This is a locus diagram. Locus diagram. This problem comes under locus diagram. This is the general basic, very basics. This is a superposition theorem. So theorems, two problems came. So we can't generalize which topic is important, and there are many other topics are there not asked any question. It happens sometimes. So with this I am closing. So these are the questions asked for GATE ECE students 2022. Thank you.